very good day to Dr. Eddie Irwan. My name is Vasantaraj Rajam and my matric number is EA20040. Today we'll be presenting our project, which is Vehicle Control System. Cruise Control System is a controller used to control the speed of the vehicle automatically as per their driver command and adapting itself to the road condition and external disturbances. The main aim of the cruise control is to provide ease to the drivers by automatically setting the speed of the vehicle. The key issue in cruise control is to maintain the cruise speed with varying environmental disturbances and the road condition. To make this possible, there are need of controllers such as PID. The proportional integral derivative PID controller is an effective and a common feedback control design used in an open and closed loop systems. It takes the proportional Kp, integral Ki and derivative Kd. In this paper, the goal is to design a PID controller using root locus technique for an open and closed loop system and a PID controller using closed loop system. Using root locus approach, the controller constants and the controller's design is finalized. Simulation results through MATLAB environment validate the effectiveness of the controller design. A cruise control system basically consists of following devices such as vehicle speed sensor, control computer, actuator to set the throttle, cancellation switches and the control button for the driver. Vehicle speed sensor. The vehicle speed sensor is to measure how fast the vehicle is traveling. The control computer is where the brains of the cruise control system is located. The control computer receives signal from the vehicle speed sensor, then sends signal to adjust the throttle to maintain the desired speed that is determined when the system is first activated. The actuator receives electronic signals from the computer and turns them into a mechanical motion that controls how much the throttle is open. Cancellation switches turn the cruise control system off. The user control buttons allows the driver to turn on the control of the cruise on and off.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nafara Alina binti Azmi. My Indian number is 502127 and I will present about the physics behind the cruise control system. So, the cruise control system, the reason is to differentiate between the earlier cruise control system and today's cruise control system. So, the earlier cruise control system with sophisticated computer programming that found into the system. So, basically, the earlier cruise control system couldn't have much and it's different than the today cruise control system. So the result in early system were not as effective at really maintaining a constant pace at the car, the throttle that was held in place, but as other forces on the vehicle changed, the vehicle speed fluctuated somewhat. So the theory behind the primary objective for the cruise control system will be to accelerate the vehicle to the desired speed, much like what happened when a driver presses the resume button. So that's the reason behind the cruise control system.
Shonanraj, my matric card number EA235. So for the project Automobile Cruise Control, I take over part methodology, result and discussion. For the methodology, we choose a car as an example to run our control system, cruise control system. So seems that our transfer function we obtain from this major equation. So after we substitute all the value, we obtain the transfer function as here. Okay, our transfer function main focus is throttle to the velocity of the car, because velocity also include mass and the gravity since it's a slope. So followed by, we go for our MATLAB. So now let us see our control system of automobile in MATLAB coding. So here the coding. So first numerator, denominator, we already stated, and then transfer function we obtain. So in root locus, we need to define it. So let us run. So here is the result. Since our transfer function, there is a no zero and got 3 poles, which is 1, 2, 3. So for the similarity is there is a no overshoot, which means our cruise control system once the engine start and then reach our particular limit around 20 km or 30 km per hour, it's just continuous rate, which means there is a no stopping or there's a no stopping to the user. So this is where it's not advisable to our current cruise control system. To improve that, we try to simulate with feedback system. So here is our feedback system. The only difference, we add a h equals to 1, which is 1 unity gain, and then obtain our result. We run our transfer function in terms of feedback system, which is unity gain. So let us see our result. So here it is. So again, there's a no overshoot yet, but the damping factor 1 and 1, 1, which is indicate that 1 unity gain. So for the user, once they press the cruise control button, the car will be accelerate. But the thing is, they can control, but it's progress. So once they accelerate, the car will be keep increasing their speed, not as a maintain a level of the speed. So to overcome this situation, we come up with a PID controller, which is a KP, KI, KD. Here the major thing, we can optimum our cruise control system with our preference. So right now we add on KP, KI, KD. This is a major parameter for the PID. If you notice, so also the same, after we set up our random values, we try to run in the transition mode. So here is our result. So saying that from the previous open loop and now we can see the improvement, which is the car automatically steady state around 60 seconds, which is 1 minute. So we can see the clear improvement. Now we try to simulate in root locus term. So once we done simulate, so this is how our transfer function will be, and also our root locus. So saying that just now there is a no zeros on our transfer function. Now we get, because of the calculation, so we have obtained for the all 4 points, which is shows the improvement in terms of overshoot and the damping factor and frequency. So now we do our automobile cruise control system in Simulink MATLAB. So here's our model. So on your left hand side is a open loop, and then this one is a closed loop. So the transfer function we obtained same as a previous one, and also goes to here. The only difference, we got a feedback system. So let us run the simulation. So here we obtain result for the open loop and also closed loop. For the open loop, the result after 1 second, the graph continues straight, which means rising up. In terms of a real world of a control system, cruise control system, there is a no stopping or cannot control the cruise, which is once the user accelerate, it's just continue without any lag or stopping. But at the closed loop, there is a different, which is until 2 seconds is a rising up, start to rising up, and then on the 7th to until the 10th second, it's performing a little bit of a drop, but also it's a steady state. So what if we run in our cruise control system in a PID control? Our PID cruise control system with a PID controller. So right now we use the initial value for the proportional integral derivative. So let us see the result in a root locus. Obtain in a root locus form, we have to go control system designer, the interface of a control system designer. So we go for root locus. And for now, we use a closed system with a PID. So then plot. Here our result, which is a 4 and 1, 0. So once we done start our simulation, we get a transfer curve of in a root locus. So what if we do our own specification to maintain this to improve our cruise control system? To maintain or to improve our cruise control system, we have to go PID controller parameter and select tune. So automatically our MATLAB will give output. So once we select the tune, we go change our parameter based on here. So 0.6, 0.02 and 0. So we can go for here. We update the parameters. We can see the result. So once we update, automatically they got a 2, which is our real one as a setup as a parameter. So if you notice that there's got an overshoot, which means it's not a good recommendation for cruise control system. By right, our dotted line, which is a block response, also refer to a good steady state, and also there is a no overshoot. So what we emphasize, we should go for a cruise control system, which is there is a no overshoot. So what's the benefit is once the user start injure and accelerate to the particular kilometer per hour, and it's steady state until the cruise control taken over by the user back. So here we set the improvement after a few run of changing parameter. So that's all from me. Thank you.
So basically, system competition is one of the mechatronics ideas that used in cars to enhance comfort and safety while driving, especially for the driver. So driving with control system will help in increasing the safety, and it's more better than environment. It's more better for the environment. So the cruise control system electronics are attached to the vehicle's main computer processing during the primary production line. So cruise control system is a type of control system that use input, output feedback loop, and computer processing. And the input and transistors in the cruise control system are fairly simple devices. While doing the reason of the comparison was to determine which situation is more better for the car safety and to warrant an improvement in a car cruise control system. And we choose case 2 after fixing the steady state error, which is the cases is more suitable to the car system. So basically, the cruise control system has many other advantages, and actually is to ensure the driver safety and preventing them from uh, speed limit violations, and it also superior to manual transmission. And the automobile will see a more steady speed as a result of the cruise control system, which reduces fuel consumption by relieving the engine's need to constantly race and burn gasoline. And that's all from us.